Hi, I want to do a quick review about successive approximations, and I had to kind of get a new contraption because my kids are tired of filming. Okay, so the first thing that I want to share with you is that basically we have two functions. We have f of x equals x squared plus 3 and g of x equals negative x squared plus 3x plus 5. And we're trying to see where do they intersect. So basically, whoops. If we had a linear function and a quadratic function, where are the points that they intersect? And if we were using a graph, you could just use those coordinates, and those coordinates would be where they intersect. You'd be looking at the x values to see where the y intersect. But what we are going to actually do is we're going to be looking at tables. So if you see this table right here, I have f of x, I have the equation for f of x and the equation for g of x. And they filled out a chart, whoever made this chart up, and we can assume that they filled it out correctly. They're not going to give us a chart that has a mistake in it. So I'm just looking for when. The question is going to say something like, when or what point is x where f of x equals g of x? Okay, so we're looking for when those are the same. Well, here are the outputs for f of x and g of x. So all I have to do is scroll right down. Are they the same? No. Are they the same? No. Are they the same? Bingo! Ding, 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 ding. So not the same, not the same. So right here we can see that f of x equals g of x when x equals 2. All right, so when x is 2, these two functions equal each other. So your answer would just be when x is 2, f of x and g of x equal each other, because they do right here. So the problem comes about when we see something that looks more like this. And if you look down this chart, I have two functions here, but when you look, you're just looking to see when are they the same. Not the same, 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 not the same. So it looks like these functions are never the same. But what happens is we just don't have the answer on this paper. So if we look here, we're going to say, okay, the difference between those is 2, and then, ooh, that's 1.75. So they're getting closer together, and now the difference is just 1, closer together. Ooh, now this difference is 0.25. That's pretty close. And then it jumps to 3, and then it jumps to 12, a bigger difference here. So if we look at this one right here, we can say they're pretty close. They're only 0.25 away. And so we're trying to see when they're the same, or at what value does what x have to be, and let's say they want us to round to the nearest tenth, that they're the closest. So because the difference between 4 and 5 is 1, and the difference between 9 and 7 is 2, whoops, I think I said 3 earlier, is 2, then I'm thinking that they're going to be closer together in between here. So even though 1.5 is pretty close, I'm going to try 1.4 and see if they're closer together at 1.4. So I'm going to basically copy down this equation right here and plugging in 1.4. So 1.4 squared plus 2 times 1.4 plus 1. And then I have to plug the same 1.4 into g of x. Just trying to make some room. 2 times 1.4 plus 3. Okay, so I'm gonna scroll focus right here on this one. And 1.4 squared is 1.96 plus 2.8 plus 1. When I don't know what I did. When I add that all together, I get 5.75. All right, so we're going to compare this with g of x. And let me scoot this aside, scoot this over. Okay, so for this one, I have 2.8 plus 3 equals 5.8. So this is f of x and this is g of x. Wow, these are really close now. Did I do that right? 5.8. Oh, actually didn't even write that down right. and this is 5.79. Make sure I just calculated that right real quick. 1.96 plus 2.8 plus 1. No, I was right before, sorry. Getting all kinds of crazy answers for this. 5.76. So these are even closer together than these are. So right now, 1.4 is looking pretty good, right? I'm looking at x is equals negative 1.4 because here it was 5.76 and here it was 5.8. Now I can go ahead and check and just check 1.3 and see, like, is it even closer? So I'm gonna plug it into the same equation, 1.3 squared plus 2 times 1.3 plus 1, and then I also have to plug it in here, 2 times 1.3 plus 3. Okay, since I'm on this side, I'm gonna go ahead and just finish this. 2.6 plus 3 is gonna get me 5.6, and I'm gonna do this side over here, and I get 1.3 squared is 1.69 plus 2.6 plus 1 gets me 5.29. So I can see those two are not as close. 5.29 and 5.6 are not as close. So I would say that 1.4 is our winner. So 1.4, when x equals 1.4, whoops, you can't see that. When x equals 1.4, that is when they are the closest. Okay, bye-bye.